Hello, these are LED Fantastic's instructions for making our 12 volt 5mm LED kit featuring 5 LEDs. Your kit also includes a resistor, 1.6 meters of wire and a pair of power connectors. You will also need scissors, wire strippers with snips or 2 separate pieces of equipment, insulation tape, screwdriver, solder, a soldering iron, and perhaps most importantly a mat or board to protect your table. So the first thing I'm going to do is divide the wire roughly in half. Now we're going to snip the wire like so, and we're just going to put one half to one side. The other half I'm going to cut off 4 approximately 10 centimeter lengths. They don't have to be accurately cut, about 10 centimeters is right. And then I'm going to bare the end of the longest leftover wire. I'm going to bare and twist the end, and what that means is that as you pull the sheath off, you twist it like that. So when you've pulled off the cover, it's all twisted. If you forget, let's do another one. If you forget and just pull the sheath off and you end up with lots of wires like that, the easy way around that is just grip the strands of wire in one hand, one set of fingers, and twist the other, and you get the same effect. Okay, so what we're going to do, I've been a bit premature on those wires, because the first thing we're going to do is join the long leg of the first LED to the resistor. And the way we do that is we pinch them both together about there and then just twist the resistor gently around there. That's just twisted to hold it together because we're going to solder it almost immediately. So here we go. Soldering iron, and get the solder ready in your other hand. We're going to just apply the heat directly to the twisted end of the resistor and the LED, and we're going to then put the solder right next to it and it will melt. Once it's melted, the job is done. You'll be able to see there's the solder flows like a liquid, then hardens, and that is totally solid. The resistor doesn't mind which way you fix it round, so it could be facing the other way. The resistor's quite happy, it doesn't matter. So what's going to happen is the power from the positive, which we're going to bring in through this longest wire, is going to come in via the resistor into the long leg of the LED. The long leg is always positive on LED. So I'm just going to solder that one there. Get my solder ready. Soldering that on there, and there we go. Okay, so power coming through the resistor into the long leg, goes through the LED and out the short leg. So I'm then going to get my second wire that I bared earlier, twist that around the LED leg, solder that in place. Okay, and then we need to join that to the next LED, so we'll twist on it, and that is also going to join to the long leg. The power always goes around the circuit, and it's going to go in the long, out the short, in the long, out the short, etc. So we always go in the long leg, in the positive, out the short. And we're going to have solder ready first, apply the heat, apply the solder, done. Okay, whilst I prepare the rest of these, I'll tell you that LEDs don't like a lot of heat for a long time. It will cause their lives to be severely compromised. You won't notice till a week later when they stop working. LEDs don't like more than about 5 seconds of the heat of a soldering iron anywhere near them. So we have to be really on the ball when we do soldering LEDs. It doesn't take long, as you've already seen, for the soldering to happen. It's just a second or two at the most, and the solder has melted. As soon as the solder's melted, the joint is made. So we've got enough wire now to join the rest of the LEDs together. So this again is the short leg. Twist that up, and here we go. You can probably count the amount of time I have the soldering iron contacting the leg of the LED, or the cathode, the negative short leg. So it's heat on, solder in, done. Okay, so then that is going to go to the long leg. You have to make sure that your power is going to the long leg, in the long, out the short. If your circuit doesn't work, the most likely cause is you've got one of your LEDs connected the wrong way. LEDs, light emitting diodes. A diode is a device that only lets power flow one way around a DC circuit. It acts a bit like a turnstile, a one-way gate. It only lets the power through one way. It won't do any harm if you put the power the other way through your LED circuit, but if you've got a one-way gate facing the wrong way, nothing will happen. It won't damage the LEDs, but nothing will happen. Okay, nearly there. So again, pinch, twist, lay to one side, apply some heat, solder, done. Then we've got one last LED, one last piece of wire, pinch that, twist that, get the solder ready. It's tempting to hold the thing down with the soldering iron and then find the solder, but that just means you'll have put too much heat onto the LED. So that's 5 LEDs joined together. What we now need to do is join the final negative end, the short leg, to the piece of wire that we discarded, put to one side earlier. This is it. I'm just going to bare that end and twist that around the final LED leg. LED legs are a bit fragile. You only want to gently bend them apart. Pinch them here if you're going to bend them apart. It makes sense to bend them apart, it makes the whole thing easier, but if you bend them a few times, they're very likely to just snap because they're very thin. Okay, so as you see, we have the circuit, we have where the power is going in and where the power is coming out, which is positive and negative. So I'm just going to bare those two ends so that we can then insert them into our socket connectors. Doubling them over for just a little bit of extra strength. Get my screwdriver, and it's going to go in the plug side with the spikes going out. Basically the power will come in through this. In fact, here's one I have that is actually got power into it, so I'm going to demonstrate with. Power always comes from a socket, and you always plug a plug into it so that there's no live bit sticking out. Okay, just insert that into there, screw it down, and the same. So all we need to do is provide power. Okay, let's plug this one in, and there you have it. Except it doesn't work. This is because the power is connected the wrong way around, which doesn't matter. We will reverse the power, and there we have it. As I said, it doesn't matter if your power goes the wrong way around a circuit. It won't damage the LEDs, you just need to reverse the power. Okay, now the most important thing that's left over is insulation. I'm just going to unplug this to demonstrate. The worst thing that could happen if these metal touches these metals, or even this bit of metal touches that metal. Okay, you're going to overdrive your LEDs, you're going to cause them to either burn out straight away with far too much power, or again have their lives severely compromised, so not last very long at all. These LEDs, if they're treated well, should last effectively forever, 50 to 100,000 hours. Okay, so what I'm doing here is just introducing a bit of insulation tape in there. Oops, it's kind of fiddly, and this is just the way I do it. You can do it any way you choose. The most important thing, or the only thing that's important, is that you cover up every bit of exposed metal in this circuit so that you can't get short circuits. So I'm just going to do a couple like that, and I'm going to do a much longer one for the first LED with its resistor. I'm just going to... It's a bit too long, but too long is much better than too short. Okay, and you can see how that's going to go. We're going to cover up that one and all the rest there. But as far as that goes, that is your 5 LEDs 12 volt kit all done.